Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink and I am one of the math specialists here at the Learning Liaisons. And we are here every Wednesday doing math together. And so it is a pleasure that I get to spend my Wednesday night with you, just working through math problems, helping you feel more confident and competent in your ability to pass this test. And so that's really why we're here. Every week we always kind of do a get to know you question to make it feel a little less like we're in a screen and a little bit more like maybe we're in a coffee shop or something. And so I will get to that. I am Amy Sink. I'm from Central Florida and I am an assistant principal right now in a middle school and high school. And I enjoy sitting here and hanging out with you, working through these math problems. Each week I have a next week section. And so in this next week section, I like to include things that you want to see me go over in the upcoming weeks. And so let me know in the comment box, what skills are you working on? What skills are you struggling with? What do you need help with? Is there a specific problem you want to see me go over? I'm happy to do that. If you can't think of anything right now, but you think of something later, let me know in the comment or find me on Facebook in our customer hub or on one of our Facebook pages and tag me. Make sure you @Amy Sink so that I see it. And I'm happy to include anything that you come across that you're just struggling with as you're studying. Before we get started, let's do some get to know you. So where are you from? What test are you prepping for? That helps me kind of guide our conversation today and helps me guide future problem building. So where are you from? What test are you prepping for? And who is your favorite Toy Story character? Seems appropriate since I'm wearing a Toy Story shirt tonight. Who is your favorite Toy Story character? Mine, I know it's going to be cliche, but I just love Woody. He is my all-time favorite. My little one loves Woody. I love Woody. So I'm a huge Woody fan. I'm also a huge Big Green Dinosaur fan. Rex, I just think he's so cute. So I like Woody and Rex. If you have never been on the Toy Story ride at Hollywood Studios. It is so good. The Buzz Lightyear ride is like the 1990s version. Maybe it's early 2000s. I don't know. But it's an older version of the game. And you like have a laser pointer and you're trying to like shoot at the little targets. But the one in Hollywood Studios is so good. So if you haven't had a chance to do that, you have to make it a priority. It is worth the wait. That's totally an aside. It has nothing to do with Math Wednesday. But hey, now you know a little bit more about me. So tonight's going to be a little bit shorter of a session, so we will not be here for a full hour, but I know that we missed last week due to just some childcare situation, and so I wanted to be able to get here and get on tonight, but it is going to be a little bit shorter of a session, but that's okay. Hey, any math is better than no math, right? So let's go ahead and get started with problem number 1. If Malachi drives at 30 miles per hour for work, he will arrive 1 hour late. However, if he drives at 65 miles per hour, he will arrive 1 hour early. What is the distance in miles that Malachi drives for work? So this is a problem that you could see on any assessment that requires you to know distance equals rate times time. This is a distance equals rate times time problem all day. Distance equals rate times time. So your GK, your Praxis core, your middle school, your high school math. But they don't give us all the information, right? So let's take a look at this. Let's call distance yellow, rate blue, and time pink, right? So if Malachi drives at 30 miles per hour, there's a rate, 30 miles per hour. He will arrive 1 hour late. So that doesn't tell us that how fast he's going, but it does give us some sort of time frame, right? And then it says, however, if he drives at 65 miles per hour, he will arrive 1 hour early. So we've got another distance and another rate, and we have another time. What is the distance in miles that he drives for work? So this is the interesting thing about this problem. We've got 2 rates, we've got 2 distances, we've got 2 rates, we've got 2 times. We don't have a distance, but what do we know? He's going to work. Is that distance changing at all? No, it's not. In fact, the distance is going to be the same no matter how fast he's going or how long it takes him. He's going to work the same place every day. So I know that my distance is going to be the same. So theoretically, I could create an equation for the 30 miles an hour or an expression and equal it to the expression for the 65 miles per hour. Could I not? Right? So I have distance equals rate times time, and then I have another distance equals rate times time. And let's call T on time. Like T is the amount of time it takes him if he's on time. So we know our rate is 30 and 65. And I'm multiplying that times a T of some sort, right? T is on time. So if he goes 30 miles an hour, he will arrive 1 hour late. So that is going to be a T plus 1 because I'm 1 hour past my on time. And if he drives 65 miles per hour, it's 1 hour early. Now let's solve this. I'm going to distribute this. So I have 30t plus 30, and I have 65t minus 65. And I'm going to solve this equation for t because that's all I have right now, right? So I'm going to subtract 30t from both sides. So 30 equals 65 minus 30. I am going to use my handy dandy calculator. $35t minus 65. I'm going to add the 65 to both sides to get the constants on the same side. So I have all my numbers or constants on one side, and I have my t's on the other. So 30 plus 65 is 95. And how do I get t by itself if it's being multiplied to something? Divide. The opposite of multiplication is division. The opposite of addition is subtraction. So if I divide both sides by 35, then I get t equals 2.71. So that is on time, right? 2.71 hours is on time. Now I can just take that and I can plug it into either here or here, and it'll give me my distance. So 30 times 2.71 plus 1. So 30 times 3.71 gives us 111.42. So 111 is the closest answer to our distance that he's driving to work. Now, if I were to do the other one, like let's say I did 65 times t minus 1, 2.71 minus 1 would be 65 times 1.71. And when I multiply that by 65, I get 111.15. So I get the same answer because the distance is the same, right? My distances are the same. I'm just changing my speed and whether I'm on time or I'm late. And so that is why we can plug it into either one and it works. All right, let's go ahead and move on to problem number 2. Go ahead and read this problem to yourself and we will get back started. What is the area of the blue shaded figure below? What is the area of the blue shaded figure below? So this is similar to one we did 2 weeks ago, and we're going to go ahead and solve this one together. So what we notice here is that we have 4 circles, but we are looking for the blue shaded area. So I have this square right here. And how do I know that it's a square? Because I've got these circles in the middle and the diameter of a circle is the same no matter what. And it would tell you some of that information. I did not include that, but it would say, what is the area of the blue shaded figure below with 4 circles inscribed inside of that figure or something. And so then I would know that I have 4 circles. And I know that the distance from one corner to the other is 8. So I know that this distance right here is also going to be 8, right? I know that the area of the whole square, if the whole thing was blue, I know that it is going to equal 8 times 8 because length times width, which equals 64. So I can already eliminate one of my answer choices because I'm only going to take the blue shaded part of that entire thing. So it can't be 64 because it's not the entire square. So it's just going to be a portion of that. 8 times 8 is 64. Now, I know that if this whole thing is 8, then half of that is going to be 4. So the diameter of this circle is 4. The diameter of this circle is 4. And that's going to be true for down here. The diameter of this circle is 4 and the diameter of this circle is 4. How am I going to find blue only? Well, I need to do the area of my square minus the area of 4 circles. I need to do the area of my square minus the area of 4 circles. So I need to do 64 minus the area of 4 circles. Well, how do I find the area of one circle? The area of one circle equals pi r squared. The area of one circle, and we disconnected, I'm going to reconnect here. The area of one circle equals pi r squared. So the area of 4 circles is just going to be pi r squared times 4, right? The area of one circle is pi r squared. The area of 4 circles is going to be 4 pi r squared. Because I have 4 of the same circle, right? If it was 4 of a different kind of circle, then we would clearly need to do something else. But they're all the same. So I am going to do pi r squared. But what is r? R of all of these circles is only going to be center to the outside, which is only 2, because it's that diameter divided by 2. So the area of one circle is going to be pi times 2 squared, not 4 squared. So that equals 3.14 times 4, which equals, handy dandy calculator, 12.56. Now there are 4 of them. So I'm going to multiply that times 4. And that equals 50.24. So now I can do 60 minus 50.24. And that's going to give me my answer, which is 13.76. Questions about that? That was a fun one. That was a really fun one. At least I thought so. Ready? Problem number 3. You and some friends are playing a game of catch. You throw the ball 5 feet forward to friend A. Then friend A throws the ball 8 feet backwards to friend B. Then friend B throws the ball 4 yards forward to friend C. And then friend C throws the ball 2 feet backward to friend D. Where is friend D standing in relation to where you are standing? Where is friend D standing in relation to where you are standing? All right, this is a fun one. So this is totally a problem that could show up on any of y'all's tests because it sounds complicated, but it's really just interpretation of a word problem. So we're playing catch. You throw the ball 5 feet forward to friend A. So let's call this me. I throw the ball 5 feet forward to friend A. Here's A. Friend A throws the ball 8 feet backward to friend B. So now this is still A, but I'm going to do different layers. 8 feet backward to friend B. Friend B throws the ball 4 yards forward to friend C. You're like, whoa, how is 4 bigger than 8? I'll show you in a minute. And friend C throws the ball 2 feet backward to friend D. Where is friend D standing in relation to where you are standing? So all of these are in feet, 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 except for this one, which is in yards. And that's where they're going to trick us. So 4 yards, 1 yard equals 3 feet. And that would be on like a conversion chart. So then 4 yards is going to be, to get from 1 to 3, I multiply times 3. So to get from 4 to feet, I'm going to multiply by 3, which is 12. So instead of 4, I'm actually going to replace that with a 12. So where is friend D standing in relation to where you are standing? All right, let's reconnect again. Sometimes my iPad decides to be super cooperative, and then sometimes it just disconnects on its own whenever it wants. And that's what it's doing today, and that's okay. All right, so now in hindsight, after looking at this problem, I probably should have drawn forward to the right and backward to the left to create more of a true number line, because I'm noticing over here that we've got negative and positive values in relation to me. But for some reason, I visualized myself throwing this way as forward and this way as backward. So I created a backwards number line, and that's okay. If you thought smarter than me, then good for you. All right, so I threw it to A 5 feet forward. Friend A threw it 8 feet backward, which means that friend B is only 3 feet behind me, because A threw it 8 feet, but I'm right here, right? Like this is where I am right here. And then B threw it 4 yards or 12 feet forward. And then C threw it 2 feet back. Well, where is C in relation to me, right? So if this is 5, this is 3. So B is 3 feet behind me, which means that C is 9 feet in front of me, which means that if I subtract 2 from that 9, D is 7 feet in front of me. Because remember, forward is to the left because I created this weird backward number line, right? Now, had I created a regular number line, but again, it doesn't really matter. It's just a visualization. So really what I did in all of these situations was I created part-whole relationships with each of these smaller number lines so that I could figure out where they were in relation to where I was standing. Part, whole. Part, whole. So by creating those part-whole relationships, I could figure out where everybody else was in relation to where I was standing so that we could figure out where D was in relation to where I was standing. Does all of that make sense? All right, we're going to do another problem similar to this problem. So let's go ahead and look at it. You and some friends are playing a game of catch. You throw the ball 5 feet forward to friend A. Friend A throws the ball 5 feet backwards to friend B. Friend B throws the ball 4 meters forward to friend C. Friend C throws the ball 2 feet backward to friend D. What is the difference between friend D and friend B? All right, this is an interesting one. And we're actually, for the sake of, and I don't know why it says meters, for the sake of conversion factors being a little bit more friendly, we're going to call this yards. I don't know why I changed it to meters. So you and some friends are playing catch. And let's just go back to this visualization that we have. And I'm going to copy and paste it all into this problem, just for the sake of time, because we don't really need to redo all of that for this problem. I just want to see I want to show you how you might do this. Okay. So we just figured all of that out, right? And the ball landed 2 feet backwards to friend D. What is the difference between friend D and friend B? Well, friend B is all the way back here, and friend D is all the way up here. So what we really want to do, if me is 0, and we're on a backwards number line, if me is 0, then friend D is at positive 7, and friend B is at a negative 3 because they're behind me. So that's negative 3 feet. So the difference, how many feet are between them? You have 7 plus an additional 3, because when I do 7 minus negative 3, it actually becomes positive, because a negative times a negative creates that positive. So the difference between them is 10, because when I subtract a negative, it becomes positive, because I need to find what that gap is, or the difference is between those two numbers. So the answer for this one would be 10. Questions? All right, we have time for one more, and then I'm going to turn it back over to Dr. A, and I will see you next week. The apothem of a square having its area numerically equal to its perimeter is compared with the apothem of an equilateral triangle having its area numerically equal to its perimeter. The first apothem will be equal to the second, half times the second, square root of 2 divided by square root of 3 times the second, 2 divided by the square root of 3 times the second, indeterminately related to the second. This is a fun one. It's a weird one, though. So the apothem of a square. I'm going to draw a square first. There's my square. The apothem is from the midpoint to a side of the square at a perpendicular angle. Now, the apothem of a square is super easy to find. I know that this side is S and this side is S, which means that the apothem is just S divided by 2, right? The apothem is S divided by 2. The apothem of a square where the area is numerically equal to the perimeter. So I can figure that out so that I can figure out this relationship. So I know that S plus S plus S plus S, which is 4S, equals S times S, which is S squared. Now I can solve this. Subtract 4S from both sides. 0 equals S squared minus 4S. Factor out an S. And now set them both equal to 0. So the side of a square cannot equal 0. So that answer is out. But the side of a square can equal 4, and that makes sense. 4 times 4 is 16. 4 plus 4 plus 4 plus 4 is 16, which means that the apothem equals 2. So we have the apothem of our square, and I'm going to take this and just shrink it down a little bit and throw it up here. And now I'm going to do the same process for my triangle. I have an equilateral triangle. And I know that the perimeter, S plus S plus S, 3S, is going to equal the area of my triangle, but I want to keep it in terms of S. Well, I know that the area of my triangle is going to be 1/2 base, which is S, times the height. How do I find the height in terms of S? Well, I know that in an equilateral triangle, these are all 60, 60, and this would be 30 because I'm cutting it in half. Well, in a 30, 60, 90-degree triangle, this whole thing is S, so this would be S divided by 2, right? And in a 30, 60, 90-degree triangle, this is X, this is 2X, and this is X square roots of 3. So then it's going to be this, S divided by 2 times the square root of 3. Following? That's the height. Now I'm going to solve. 3S equals 1/2 S squared, square root of 3 divided by 2, which is s squared square root of 3 divided by 4. Yes. Subtract 3s from both sides. 0 equals s squared square root of 3 divided by 4 minus 3s. Same thing, pulling s out. 0 equals s square root of 3 divided by 4s minus 3. Following? And now set it equal to 0. Square root of 3 divided by 4s minus 3 equals 0. Add 3 to both sides. Add 3 to both sides. And multiply by 4 square roots of 3. 4 over the square root of 3. Yes. So s equals 12 over the square root of 3. But I'm going to multiply that by the square root of 3 over the square root of 3 to get rid of that square root of 3 in the bottom. So s equals 12 square roots of 3 divided by 3. And when I simplify that, that equals 4 square roots of 3. Now, keep in mind, that is the side of my triangle. That is the side of my triangle. The height of my triangle is this mess. The height of my triangle is this mess. And if the side is 4 square roots of 3 and height equals s divided by 2 square root of 3, then I can plug height in for, or the s in for s, right? So 4 square root of 3 divided by 2 times the square root of 3, right? Following. That equals 4 square root of 3 times the square root of 3 is 9 times, right? So 4 times 3 is 12 divided by 2 is 6. And I know the apothem of an equilateral triangle is 1/3 the height. So 6 times 1/3 equals 2. Wait a minute. The apothem is 2 for my triangle also, which means the apothems are what? Equal. Tell me that wasn't a fun problem. Some of you are like, I'm taking elementary math. I do not need to know how to do that. I'm taking GK. I do not need to know how to do that. Well, you're right. But that was a fun problem for us middle school and high school people. So it was a good one. All right. I hope that y'all have a great week. I look forward to seeing you next week. Please let me know if there's anything that I can go over in the upcoming weeks in these math sessions. And I look forward to seeing you soon. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.